identify the critical points, the intervals of increasing and or decreasing, and any local extrema for f of x is equal to sine of x minus cosine of x. All right, so here we're, I guess, finally dealing with trig functions. Okay, so we got sine of x minus the cosine of x. Okay. All right, so first we want to find the derivative, right? So f prime of x, whatever the derivative is here. Now, once again, trig function, but there's a minus sign here, okay, which is actually not too bad because we could just use the laws of derivatives, right? The derivative of sine is cosine of x, I know that. And the derivative of cosine of x is negative sine of x, which gives me plus sine of x, okay? So this is the first derivative. So to find the critical values, we need to set this guy equal to 0 and solve. Okay, there's a couple ways to do this, right? I can bring this over to the other side, right? So we can ask yourself, okay, where does the cosine of x equal the negative sine of x? Or we can, if you have a unit circle, you can try to figure that out. Okay, or what we can do is divide both sides by cosine. So 1 is equal to sine over cosine, right, which is tangent. So, okay, where does tangent equal negative 1? Okay, that one may be a little bit easier to deal with, right? We know that tangent is equal to negative 1 at 3 pi over 4 in quadrant 2, okay, and 7 pi over 4, right, which is in quadrant 4. Okay, so these are our critical numbers. Now, there's one extra wrinkle here, right? Notice I didn't give you any restrictions, right? So for this one, I guess we could deal with a little bit more on the conceptual level, right? I know that 3 pi over 4 and 7 pi over 4 are my critical numbers, right? Just the values within 2 pi, okay? But, okay, I can keep adding, subtracting multiples of 2 pi here, right? And I'm just going to get more intervals, right? 7 pi over 4 plus pi is 11 pi over 4. We can keep going on, actually, in every direction, right? Another thing we do know, however, is that this is going to have some wave type feature, right? Okay, so let's go ahead, right? This, we know, is our derivative. Okay. So we can just go ahead and plug in some values here, right? We can plug in some, I don't know, something like 0, right? We can plug in like pi, right? You can plug in something like 2 pi in here, okay? And just sort of see what happens, okay? So once again, f prime of 0, we can plug in f prime of pi, f prime of 2 pi, and sort of see what's happening, right? This is f prime, right? What is f prime of 0? Okay, cosine of 0 is 1, sine of 0 is 0. This is going to give us a positive result. Okay, this is going to be positive here. Okay, what happens if you plug in pi, cosine of pi, sorry, plus the sine of pi? That's going to give us a negative 1. Doesn't matter what the number is. All that matters is that it's negative, right? When you plug in 2 pi in here, okay, same thing, right? We get 1 plus 0. We're going to get positive result, and this pattern is going to keep repeating. Okay, once again, this is a trig function. It's going to exhibit, right, some wave feature here, okay? So where is this function going to be positive? Okay. Well, negative pi over 4 to 3 pi over 4, and then 7 pi over 4 to 11 pi over 4, and every multiple of that, right? And this function will be negative or decreasing. Okay, so decreasing from 3 pi over 4 to 7 pi over 4. Okay, and then, well, I guess we can just do the union, right? So we'll do the union, everything from here, right? 11 pi over 4 to 15 pi over 4, so on and so forth, right? Okay. Once again, this is just a little bit more for a conceptual idea here. We also see that we change from decreasing to increasing, right? Increasing to decreasing. Once again, I'm not necessarily going to draw this out, but we have some waves like this, right? Just increasing here, decreasing here, right? Increasing here, decreasing here, so on and so forth, okay? All right. So what's going to happen then? Okay, what's going to happen? Okay. Well, we have a maximum here, right? So we have a maximum at 3 pi over 4. Okay. where else are we going to have a maximum? At 11 pi over 4. And every 2 pi multiples of that, right? Every 2 pi multiple of that. And similarly, we're going to have our minimums. Right? We can count negative pi over 4, I guess. It doesn't really matter, right? Once again, just doing a little bit more conceptual work here, right? So negative pi over 4 here, 7 pi over 4, right? And once again, add or subtract 2 pi in every direction. Those are where your max and mins are going to be.